In the last few tutorials, we have faced difficulties in passing state between page and components. The most troublesome part is to update the parent component states from a nested components. With React Redux, we can simplify the sharing and updating of the application state between components. React Redux is a must-learn topic for React and React Native developer. Welcome back to Just Code China. Please support us by subscribing to our channel and like our video. If you have any question in this tutorial, please leave a comment below. Today's tutorial, we will continue to modify the dictionary app we have created in the past tutorial to illustrate how to use the Redux state engine to simplify state passing between components. First, let us see the difference between the component state and Redux states. From the diagram on your left, we can see the apps using the React component states. Within the apps, each component will have its states. Each component state is isolated within the individual component. The only way to share state between components is to pass the state to the other components as properties. To update the parent component state in a nested component, we need to leverage on the method passed into the nested component via the property from the parent components. Now, from the diagram on the right, we can see the app uses the Redux state. Within the apps, the state is located in the centralized store. To access the Redux state, the component just need to connect to the Redux store. To update the state, the component needs to dispatch an action to update the respective states. From the diagram, we can see that the Redux state is not restricted within any component. Any component in the app can access the Redux state as long as the component connected to the Redux store. Let's equip ourselves with some basic knowledge on React Redux. The React Redux consists of action, reducer, and store. Action is a method that returns an action object. With the help of Redux trunk middleware, an action can also return a method. The action object consists of action type and payload. The action type is used to identify what action to perform, and the payload is the parameter used to update the state. The reducer is a method that subscribes to the action. It listens to the action dispatched by the app and updates the state in the Redux store accordingly. The store is a place where Redux initializes and holds the state. The steps of using the Redux state engine are as below. First, we create the Redux action, reducer, and store. Then, we link up the Redux provider in the app. Next, we connect the component to the Redux store to access the Redux state. Last, we update the Redux state by dispatching an action so that the corresponding reducer will update the Redux state. Before we start coding, we need to install a few npm modules required by the React Redux. Let's bring up our terminal screen. Make sure you are in the project root folder. The modules we are going to install are Redux, React Redux, Redux Logger, Redux Trunk, Redux Promise Middleware, and Immutable. Type the following commands as shown and press Enter. The Redux is the base module for Redux state engine. The React Redux module is the official React binding for Redux. It allows our React components to read and update data in the Redux state. The Redux trunk is one of the Redux middleware. It allows us to write action creator that return a function instead of an action. The trunk can be used to delay the dispatch of action or to dispatch an action only if certain condition is met. The Redux Dogger is a middleware to display the Redux state in the console log. It is normally used in the development phase. The Redux Promise middleware is a middleware that enables simple yet robust handling of async action creators in Redux. Given a single action with an async payload, the middleware transforms the action to separating pending action and separate fulfill and reject action, representing the states of the async action. The immutable module allows us to create immutable JavaScript object and array. It is a useful tool to use in Reducer as the state needs to be immutable. Let's bring out the VS Code with the project folder open. Now, we are going to perform the first step to set up the Redux. Let's create a Redux folder under the source folder. Within it, we will create the action, reducers, and store folder. In the actions folder, we will create the action-tab.js file to hold all the action tab definition. For a start, we just define the set language, show camera, and set profile photo action tabs. In the same folder, we will create the UI action.js file to hold the action method. We normally name the method according to the action tabs. The first method is the set language. It will take in the lang parameter and return the action consists of the tab and payload. The tab is the set language and the payload will be the lang parameter. This action will be received by the corresponding reducer, which will be shown later. In the set language action method, we also save the new language into the device storage before returning the action. The next two action methods, we will just return the corresponding action as shown. Now, we will create the UI reducer under the reducers folder. We will import the action tab and immutable module. Next, we will create an initial state method to return the reducer initial state. Please take note that the return state is an immutable map object. We use the from.js method to create an immutable map object from plain JavaScript object. The show camera state is used to determine when the camera module will be displayed for profile photo taking. The lang state is used to hold the language code to be used by the entire app. The profile photo state holds the profile photo for the user and it is set to icon.png by default. Next, we need to create the reducer method that takes in the state and action as parameter. When the reducer runs for the first time, it will get the state from the initial state method. After that, it will receive the last state from the Redux engine. Most of the developers like to use a switch statement in the reducer to handle different actions. However, the major drawback for using a switch statement is that when the apps get bigger, so will the switch statement. This makes it hard to read and modify the code. I would like to use the JavaScript object prototype to make the code neat and simple to maintain. First, we will check if the function to handle the respective action is defined or not. If defined, we will invoke the function by passing in the state and action as parameter. If it is not defined, then we will just return the existing state without changing it. That's all for the reducer. Isn't it neat and simple? Now, we need to define the function to handle the respective action in UI reducer. For example, we will use the prototype to add a method to handle the show camera action. This method will update the show camera state by calling the set method with the payload as the parameter. The set method will return a new immutable map object. It then returns a new map object to the Redux state engine. Therefore, every time we call the set method, a new immutable map object is generated. This makes the Redux state immutable between states. Let's define the method for set language and set profile photo similarly. Next, we will create the index.js under the same reducer folder. Indeed, we will import the UI reducer we have just created and the combined reducer from the Redux module. The combined reducers allow us to combine multiple reducers into one so that it can be used by the Redux state engine. For now, we will create a combined reducers that only consists of UI reducer. We will add more reducer in the later part of this tutorial. We have done for the action and reducer. Now, we are going to create the Redux store. Let us create a store.js file under the store folder. In the file, we import all the Redux related module and the combined reducer we have just created. Followed by, we will create the middleware by using the apply middleware method. We first check the app's runtime environment is in production or development mode using the dev global variable. In the development environment, we will create the middleware with the Redux promise, trunk, and logger. In the production environment, we will create the middleware only consists of Redux promise and trunk. The Redux logger is only used for development. Next, we will create and export the Redux store with the reducer and middleware as shown. That's all for the store.js file. Now, we're going to perform the second step to set up the Redux. That is to link up the Redux state engine with the application by specifying a Redux provider for the app. Let's open the index.js file in the project root folder. In it, we import the React Redux provider and store. Then, we create a functional component called Redux app to wrap around the apps with the Redux provider and store. Next, we change the registered component app to Redux app. We have completed the second step. The third step is to connect the component to the Redux state engine. To do that, let's open the app.js file in the root folder. We will import the connect method from the React Redux. Scroll down to the end of the file. We will connect the app to the Redux state by calling the connect method before exporting the app component. In the connect method, we specify the state the app component needs to access. Once the component is connected to the Redux state, the component can access the state via the component's property. Scroll to the app's constructor method. Since the app's component is now connected to the Redux state, we don't need the local component state anymore. So, we can remove the entire constructor method. Now, scroll to the app's render method. To access the length state in the Redux engine, we simply change the local length state to this.props.ui.getLength. The UI state is bind to the app's component property. Since the UI state is an immutable map object, therefore, we need to call the get method to access the length property in the UI state. I show you how to access the Redux state in the component. Now, let me show you how to dispatch an action to update the state, which is the last step of using the Redux state engine. Scroll to the component dipmount method. Let's modify the setState method in the then block of the getDeviceLanguage from storage method. We will invoke the dispatch method in the blobs. In the dispatch method, we will invoke the setLanguageAction method to return the Redux action. This is how we update the Redux state. We will do the same thing in the catch block but set the language to English. Next, we will do the same thing for the profile photo by dispatch the setProfilePhoto action. We will remove the existing updateAppLanguage method in the apps component. This method is used for the setting page component to update the apps component state when the user changes the user interface language. Since the setting page can access the Redux state directly, which I will show you later, therefore, we no need the updateAppLanguage method anymore. Back to the appRender method, we will remove the toggle camera, profile photo, length, and updateAppLanguage property for drawer nav, since all the subcomponents now can access the Redux state directly. This is how Redux helps us to simplify our code. Next, we update the onClose property method and remove the length property for the camera module. Scroll up to the drawer nav functional component. We will connect the drawer nav component to the Redux state as shown. We will remove the toggle camera and profile photo properties for drawer content component. Next, we will remove the tab nav and profile child element in the drawer.screen component, as we can pass the tab nav and profile via the component property. In the drawer content component, we will change the way we access and update the state as shown. Now, let's scroll to the tab nav component. We will connect the tab nav to the Redux states as shown. We will make similar change as drawer nav by removing the child element for each tab.screen component and pass the child element via the component property. Now, we are going to modify the setting page. Open the index.js file under the screen setting folder. As usual, we import the connect and UI action. Then, we connect the setting component to the Redux state at the end of the file and rename it as Redux setting. Scroll up to the setting component and remove the constructor as we don't need it anymore, since the length state has moved to the Redux state. In the render method, we will change the length component state to the Redux state as shown. In the updateLanguage method, we will remove the existing code. We just need to dispatch the setLanguageAction to update the length state in the Redux state. Once again, this makes our code clean and neat. Next, we will modify all the remaining page components to connect to the Redux state and change the length component state to Redux state in the render method. We have completed all the changes for now. Let's run the application in the simulator. The app has launched in the simulator, and let us place a few breakpoints in app.js, UIAction.js, UIReducer.js, and index.js under the setting folder via the debugger browser. Reload the application in the simulator. Immediately, the first breakpoint in app.js component.mount method will be fired. Press F8 and the app will read the language setting from the device storage and fire the next breakpoint. Now, the app will try to dispatch setLanguage action. Let's press F8 again, and the setLanguage action will be fired. In the setLanguage action method, it will save the latest language to the device storage and return the action with the payload containing the latest language code. Press F8 again, and the reducer for handling the setLanguage action will be fired by the Redux engine. The reducer will update the lang Redux state with the payload received. Take note that in the simulator, the app is still on the default English language. Once we press F8 to update the state, the app in the simulator will update the user interface language to Chinese. This is the life cycle of Redux to update its state. Now, let us switch to the console screen and you will see the logs created by the Redux logger. Let's focus on the UI setLanguage log. The UI setLanguage is the action we define in the action tab.js. Within the log, we have the previous state, action, and next state. The previous state contains the state before the action is fired. Let's expand the previous state to take a look at the language state. Now, let's expand the action to see the content of the action. It contains the action tabs and payloads. Next, let's expand the next state. We can see the language state has changed from EN to ZH. That is the reason why the Redux states must be immutable, as Redux engine keeps track of individual states within the app lifecycle. I had covered the basics of Redux state engine. Now, let us touch base on a more complex situation. That is, to use the Redux state engine to handle the asynchronous tasks. This is made possible by using the Redux trunk and Redux promise middleware module. We'll use the flavor page as an example. First, let us define the new action tabs for the flavor page in the action tabs.js as shown. The new action tab will have the pending, fulfill, and reject at the end. This is to indicate the life cycle of an async task. When the async task is just fired, the action tab will be pending. After the task is executed successfully, the action tab will be fulfilled. If there is an error during the execution, then the action tab will be rejected. We will see how these three action tabs work in a short while. Now, we will create a new reducer called pageReducer.js. This reducer will handle all the page-related state operation. Similar to the UI reducer.js, we start by defining the initial state method to return the initial state as shown. Followed by, we create the main reducer method. Next, we will create a method to handle the pending, reject, and fulfill action as shown. In the page flavor load list pending method, we set the loading to true to indicate the task is still running. In the page flavor load list rejected method, we set the loading to false to indicate the task is completed. Since this is a reject action, we'll also set the error message to the received payload. In the page flavor load list fulfill method, we will set the loading to false, load to true, flavor list to the received payload, and set the error message to empty. Please take note that I'm using the setIn method to update the state instead of set method. The reason is that the state we define for favorite page have nested property instead of a single level object as compared to UI reducer.js. The setIn method is similar to set method, just that it takes in an array of nested properties. We had done for the page reducer. Now, let us open the index.js file under the reducer folder. We need to import the page reducer we have just created and add it to the combined reducer. Next, we will edit the favorite page index.js file. First, in the connect method, we will add in the page state. Scroll up to the favorite class component. We will remove the class constructor as we don't need it anymore. In the load favorite list method, we can dispatch the pending action before calling the helper.getFavoriteList. Next, in the then block, we can dispatch the fulfill action, followed by, in the catch block, we can dispatch the reject action. However, this is not the best practice for using Redux engine. Instead, we should shift the business logic of getting the favorite list into the action method. To achieve that, let's create a page action.js file in the action folder. In page action.js file, we first import the action tab and helper. Next, we create and export a method page favorite load list. In it, we will return a method that taking dispatch as the parameter. In the return method, we will first dispatch the pending action with now payload. Then, we will invoke the helper.getFavoriteList method. When the getFavoriteList method returns a result in the then block, we will dispatch the fulfill action with the result placed in the payload. In the catch block, we will dispatch the reject action with the error placed in the payload. Now, let us switch back to the favorite index.js file. We will import the page action.js we have just created. Then, we will dispatch the page favorite load list action. As you can see, this made the code clean and neat by separating the business logic code from the user interface related code. Scroll to the swipe list view component and replace the favorite list component state to the Redux state. We will do the same for the listEmpty component method and the activity indicator components. Save all the changes and let the app reload in the simulator. Bring out the debugger browser and place a few breakpoints on the favorite index.js, page action.js, and page reducer.js file. Now, let us click on the favorite tab in the app and the load favorite list method will be fired. Press F8 to dispatch the page favorite load list action. The breakpoint in page favorite load list action method will be fired. When we press F8, it will dispatch the page favorite load list pending action. The reducer to handle this action will be fired by the Redux engine. In the reducer, it will update the loading state to true. Let's press F8 again, and we will back to the page favorite load list action method. Now, we have the result returned by the getFavoriteList method. Press F8 again, the app will dispatch the page favorite load list fulfill action with the result in the payload, and the reducer that handles this action will be fired. In the reducer, it will update the state loading to false, load to true, and the favorite list to the received payload. Press F8 again, and you will see the app in the simulator list out the favorite word list. Now, let us switch back to the console log in the debugger browser. You will see the log for the pending and fulfill action that the app has dispatched. Let's expand the log to see how the state changed. We will see the page flavor load list pending action will change the loading from false to true. And the page flavor load list fulfill action will change the loading, load, and flavor list state accordingly. Till now, I have shown you how the Redux state engine works for normal action and async action. You might ask, when should I use Redux? Should I only use Redux and don't use component state at all? Or can I mix component state and Redux state? Below is some advice that I can give you. If your application page needs to share state, then it is best to use the Redux state. For the custom component, I prefer to use the component state to maintain its reusability. And yes, you can mix component state and Redux state within a page component, but I will not prefer to mix as it makes your code more difficult to read. We have come to the end of this tutorial. Today, I have shown you how to use the Redux state engine in the app and how it simplifies the sharing of states between components. If you have any question regarding this tutorial, please leave a comment below. You can follow the link to get the source code for this tutorial on our GitHub page. If you find our video useful, do support us by like our video, subscribe on our channel, and click on the notification bells. Thanks for watching. Bye.